and today we're diving into a fascinating and honestly pretty challenging work, one that raises questions at the very heart of modern physics. We'll be exploring some key ideas from Resolving the Failures of Modern Physics by S.C. Sayles. So, where do we begin? Modern physics is in many ways a story of stunning triumphs. Think relativity, think quantum mechanics, think all those Nobel Prizes, but physicists have also found themselves stuck with some headaches that just refuse to go away. C. Sayles' book steps right into this tension, taking on what the author calls the failures or persistent problems of physics. And, there's a lot there. Let's ask the core question. What is the real fabric of reality? How can our laws of physics be so precise and yet so weirdly incomplete at the edges? Why do we keep inventing things like dark matter and dark energy when we can't seem to find them? Why do relativity and quantum mechanics, our two sharpest tools, refuse to play nicely together? Now, maybe you haven't lost any sleep over the cosmological constant problem or spent your morning thinking about wave-particle duality, but here's why it's significant for you, me, and, well, anyone who wonders what this universe is actually made of. Physics powers our technology and shapes our sense of existence. If its map of reality has cracks, that's more than just some ivory tower fussing. So what does S.C. Sayles propose? Let's break it down. The central idea is that physics hits a wall because it's missing something crucial, a fundamental substrate of reality, not made of matter or energy, but of information. Sayles calls this the information field instead of patching problems with new particles or unseen forces. The book argues that what's missing is an underlying informational field that encodes the laws of nature themselves. Okay, so wave-particle duality, entanglement, stable laws, and those nagging dark anomalies. Sayles says, look, these aren't just puzzles in need of another layer of complex math, they're signposts pointing at a deeper issue. Our entire framework is missing the bedrock. Imagine asking, what's the operating system of the universe? Not the hardware, the stars and particles, but what runs the whole show. Sayles says, it's information, not stuff. Let's talk about those key findings, or really, arguments. The information field is, in this book, not a metaphor, not poetic, but an actual proposed substrate. For example, the speed of light, the values of constants. Why are they so precise, so steady? Because according to Sayles, the information field is continuously encoding them. And anomalies, dark matter and energy, quantum entanglement, they're not signs of missing pieces, but signals that we're expecting the wrong kind of answer. Let's go a little further. What about things like tides acting out of sync with the moon, or entangled particles somehow sharing a connection regardless of distance? Sayles points out that these are really weird if we're imagining everything must be mechanical, like tiny billiard balls bouncing around. But if things are encoded informationally, these spooky connections start making, well, a new kind of sense. Now, how's all this supposed to change your perspective? Well, if you're a student or just a curious soul, Sayles is sort of encouraging us all to stop thinking of the universe as only a machine running by accident. What if you thought of nature as being grammatically structured, like language, like software? What if the laws we observe are really decrees of this deeper field, not emerging at random, but sustained intentionally? That changes how you interpret almost everything. Sayles also ties this idea into philosophy and theology, connecting the information field with the concept of the logos, meaning the rational order or word that some traditions say underlies creation. Sayles is just blending the tools of science, philosophy and theology, trying to solve stubborn mysteries with a new lens. Methods-wise, the approach isn't crunching new data with experiments. Instead, it's an ontological pivot. That means Sayles wants us to rethink what reality really is, not just how we describe what we see. The book points out that our best experiments fit our models, but our models don't fit together, and then says, maybe that's because we're missing something foundational. Takeaways for you? Well, even if you're not a physicist, there's something liberating here. Science is always evolving, always questioning its roots. The fact that physics struggles with these paradoxes isn't a sign of weakness, but a call to keep exploring. The information field, whether you like it or not, is an example of what happens when thinkers push beyond patching problems. They try to rewrite the whole script.